Hello everyone, and thanks for making today's session. Glad you could join us. My name's ch9, and I'll be your guide for the next hour as we talk about the Entity Framework and the release of Code First. I'm a .NET developer based in Austin, Texas. Currently work for Proficient. Mainly we do Microsoft professional services, and again I do .NET development, web-based, Windows-based, recently MVC-based applications, a little bit of BizTalk and SharePoint. I've always had an interest in Microsoft's releases of their data access technologies that are usually released with their major releases. And Code First is no different, and I'm real excited by what I'm seeing. So glad to be here to be talking with everyone about this technology preview. Code First is an extension onto the current release of Entity Framework. So Entity Framework is currently in 4.0, as we all know, with Visual Studio 2010, and Code First is an extension to that. It's going to allow us to have support and for fine-tuned integration and adaptation between our software domain layer and software model and our database layer and infrastructure. And Code First also is introducing a new paradigm shift by which we're shifting us slightly away from database-centric applications and going more towards a domain and software-centric approach. Code First is currently in Community Technology Preview 5 right now, CTP 5. I do hear this is the last CTP, so we should be getting an official release pretty soon. And currently I do know the ADO.NET team is accepting feedback and working on the change set for the released version coming up. I'm sure as a lot of you guys know, there's a lot of support right now out in the community starting to gather around Code First and starting to get developed. So developers have been waiting for this functionality for a while. The built-in functionality for us to have persistent ignorant POCO objects, data transport objects, or domain objects that really don't have any tie to the database or any type of other infrastructure, but that at the same time seamlessly integrate with these layers. So it's something developers have been waiting for, especially those in the domain-driven design communities and agile development communities. Code First is currently being mentioned already in academic sources such as some of the current books out right now on Entity Framework, and also in just a ton of blogs and articles. Also, as I had mentioned earlier, the community is really working with the ADO.NET team right now on features and feedback for Code First. So as far as a session introduction, we're sort of going to go through a high-level and conceptual and technical overview of Code First. We're sort of going to browse its object model and the methods and classes and properties and objects that are available to us to use in the Code First paradigm. We're going to look at a very light sample MVC demo application that's using a data access layer using Code First. And then we're going to review the code base as related to the sample application and start to see where the rubber meets the road, if you will, with Code First and how to really use it in applications. And then we'll go through some extras such as transaction scope, how to use connection strings, and some validation work. So let's get going with sort of asking ourselves some questions or talking about briefly for, why Code First? Why is Code First important? Why, did Microsoft invest the research and development? Why is it being released? Why do we as developers care about it, and why is it important to us, and how can it be an asset to us in our development toolbox? And so one thing to sort of get out of the way first is that Code First is not a replacement of the current Entity Framework or Entity Framework at all, but it's an extension onto it. So as we'll see later, it's part 3 of 3, if you will, as far as Entity Framework's life cycle. So as far as its place in the life cycle of Entity Framework, we had the database first option, as we all knew it. we right-click on the visual designer, as we all remember, and create our model from the database using a connection string, and the database sort of gets represented in a visual model for us with the backing XML in the background, the conceptual and store models and database models. Then we had support and release for model-first development, by which we could create our model in our visual designer and then have SQL script and schema generation scripts automatically generated for us, and then we could run those and actually create our database manually that way. In between there's been different ways to get at code first like behavior, mapping abstractions, the auto-generated classes in the entity framework. Database first were actually attributed as data contracts. So you did have access to get sort of a genericized version of POCO objects, if you will, but it wasn't real out of the box. So now with Code First, as I mentioned, part 3 of 3, we now truly have a seamless integration and adaptation with the infrastructure layer. Just out of the box. It's a first-class citizen now and something we can really use. And it also is, like I had mentioned earlier, really going to start to provide focus on the domain and software model, or allow us to have focus on the domain and software model. Another option with Code First is what I've sort of been mentioning through this introduction is just, again, the decoupling and persistent ignorance. So POCO objects have been in our world for a while now, and of course, but they've sort of been a buzzword the past couple of years. The domain-driven design approach, the repository pattern, how to deal with these plain old CLR objects that are just generic representations of our software model or our domain model, and again, that don't have any relations to any type of database or anything. So we're going to get this decoupling of the infrastructure and services, and between those and then our software model. So a true decoupling right out of the box. And one of the things that I've found over the past couple of months with Code First is that it's very easy to use. So as we'll see, we can get up and running very quickly with the API provided to us. And Code First supports constant and frequent refactoring. So again, those of us in agile shops or on agile type projects where things are really changing on us and our software model could be changing and our domain could be changing, you're going to be able to refactor as often as you'd like, and really Code First will keep right up, and it'll provide, again, that mapping between your software and the database pretty seamlessly. So one thing that's going to be a theme throughout the rest of this session is the object model that Code First provides us. So we have a very rich object model that provides us a lot of options and customization of use. So we have access to the underlying object model, and that's provided, and we have very fluent and customizable approaches that we can take towards our architecture using Code First. And finally, we have convention versus configuration. So as we'll see later on in this sample, Code First provides us several ways and several different mechanisms that allow us to configure our POCOs or configure their expressions or representations in the database. So the whole sort of approach with Code First is we have these POCO objects, we have our domain and software objects, and we want those persisted and expressed in the database in as columns in a database table, as database tables, as the database itself. And so we have several options with the convention and the configuration. So the convention approach, which is sort of the out-of-the-box functionality you get, is very similar to, say, like an MVC controller, the model binder object. You just get a post, and the model binder, whether it's JSON or the posted data, is going to know how to create these typed objects for us. And I'm sure we all love that in MVC. When we post data to our controllers, we have this strongly typed object now. So that sort of auto-magically concept is also in Code First, whereby by convention Our database is going to be created for us. It's going to be named by convention. Data types will be created for us by convention. Relationships, foreign keys, and primary keys, and again the name of columns and the field lengths and required fields and whatnot sort of will all happen for us out of the box, really without us having to do anything other than press F5 and run our application. On the other side of that coin, however, there is a very strong approach that we can take with configuration. So we have much more granular control via its configuration, and we have a lot stronger support for enterprise level configuration. And this is going to be done through two ways, and that's going to be using the new Fluent API that's been provided for us to use with CodeFirst, and we're going to look at some of those samples a little later, and also data annotations, data annotations are attributes and/or decorations that can be put on our POCO objects. Data annotations, of course, were released with a 3 or 3.5 version of .NET Framework, but with CodeFirst, some new annotations have been added to that namespace that have explicit meaning within CodeFirst. So let's talk about our sample MVC application and what we'll sort of be looking at and how it plays a role in this presentation. So we're going to go through a sample demo application using, like I'd mentioned earlier, a data access layer built on CodeFirst. And we're going to demonstrate several high-level concepts. First of all, we're going to show how mappings happen between POCO objects and the database. We're going to look at some of the database initialization options that are provided to us. We're also going to look, like I just mentioned, configuration using data annotations and the new Fluent API. And we're going to look finally at some inheritance and relationships and how we can support type hierarchies and relationships and inheritance within our application. So let's go ahead and run the application. So here we have Visual Studio, and let's press run. So here you can see we have just a light MVC application using the new Razor View engine, which is pretty awesome, by the way. I really love that engine. And let's just sort of browse through here real quick. So here we have a listing of categories with some CRUD operations we can do. We have our listing of products here. We have some sales orders here, listing of sales orders. So nothing really wowing us out of the box, but the real magic is under the covers and how CodeFirst is allowing this to happen. So let's look at a couple of light relationships here, as we'll use them as examples in our when we look at the code base. So here we have a listing of categories, so we can go ahead and click on a category such as books, and we can see the books that are part of the that actual category. So we have a couple of books here, and we can go to, let's go look at products. So there we saw a one-to-many relationship between category and its products. So again, not a big wow factor, but CodeFirst makes it real easy. So here we have, let's show a many-to-many relationship. Here we have these different products, and now we can go view all the orders that this product lives in or has been a part of. So let's go to our C# Unleashed book and click on that, and we can see this was part of this order. And then going the other way, back from right to left in this many-to-many relationship, we can see the products that are part of this order. So here we can go look at this order and see that we had a cast iron pot, a Ginsu knife, and C# Unleashed book. So again, this is really these light relationships that we're seeing here we're going to look at right now as we get into the object model and start looking at some code. And then we have this transaction example that we'll look at a little later that will just sort of show us how to, some of the gotchas around transaction support with CodeFirst. So let's go ahead and close this. Now let's talk about an object that we'll be very familiar with. And here we go, live TV. The DB context. So the DB context object is conceptually similar to the object context. So as we remember or are currently using in the entity framework with database first and model first, we have our object context. It's the conceptual representation of the database, and it serves as the entry point into the database, and a lot of the main methods such as save all changes and adding and deleting of entities, they all sort of happen from this context. So with code first, a couple of new objects have been released that we'll see right now as we go over them. But the main one is this DB context. So again, it's conceptually similar to our object context. In the DB context, we're going to see some important overrides. One of them is on-model creating. So the on-model creating override is going to be an event that's going to run within a DB context. And it's the point at which we can start to initialize or start to map start the mapping process, if you will. So on-model creating is the entry point of where we actually start mapping our POCOs and how we need them to persist into the database. So as far as setting properties and relationships and other behavior criteria. The model builder is an object that's provided to us in the on-model creating event that is going to have the namespaces and methods and classes that give us the ability to actually map and model our POCO objects using the Fluent API. So we have the DB context, and we still have, though, access to the underlying object context. So a little later in the example, we'll actually see where we actually need to get to the underlying object context. And that's done through an interface, iObjectContextAdapter, or it's done by casting our context to that type. And that gives us access to the underlying object context. So we can get into a lot more granular control of our DB context when we cast it to this type. So we can get the methods such as accept all changes and get into the database and into the ability to run native SQL against our context and whatnot. And one of the other big objects we have within the DB context is the DB set object. And the DB set is the representation of a table reference used by the DB context. So we'll look at code right now, but as we look at code, we'll see in the DB context the tables that make up that database are represented via our POCO objects, but those POCO objects are set using this DB set notation. And so we'll take a look at that. So one other guy is the DB database. So the DB database object again lives. It doesn't live with the DB context, but it definitely lives side by side with it. And what it is it's a representation of the database based on our current objects. So some of the main methods it's going to have that are going to be important to us are the set initializer method and the default connection factory method. So let's go look at a DB context and start looking at the code base and what it looks like. So looks like I was running here still. So here we have just a light little solution here, and here we can go look at a context. So one of the things to realize with Entity Framework and Code First is that we have to build out all these objects. So we have to build out our DB context object. It's not going to be done for us. We don't really have the model or visual designer, so we sort of have to fall back on building these objects ourselves. But as I mentioned in the introduction, we have a very rich API and object model that allow us to really put these things together very closely and easily. So one thing you'll notice is just a regular class, but you'll notice right here that the class needs to derive off of the native DB context object. So as we create the context, as we go create the software representation of our database, you create a class and then you just derive it off of DB context. This automatically adds this class to Entity Framework's mechanism, and it can be used as a context throughout your code base. So we'll notice here that we have our DB sets, which are our tables. So here's a DB set object, and all they are generics where we just put in our POCO objects. As you can see, we give them a name, usually plural. These are actually going to be persisted as tables in our database, and then they're just getters and setters. So we'll look at a couple of CRUD functions later, and you'll see how we use the DB set object and call set on it to really set up one of these tables, and then it allows you to get into methods such as add and remove and update. So again, that's how we're starting to, we need to build, as we're building out code first and we're building out our code first architecture, we need to create programmatically our context. So we need to create our class, we need to have it derive off of DB context like we can see here, and then we need to add our tables here and have them expressed as these DB set objects. So let's look at the on-model creating. So as I had mentioned, once we derive a class from the DB context, we're automatically going to get access to this on-model creating. And you'll notice here that it's an override, of course, and it has a type parameter in it automatically, which is of type model builder. So again, model builder, as we had mentioned earlier, was is the API object that allows us to get into the configuration world of our POCO objects. And so with model builder, here I'm using one of its methods by just adding a standalone configuration file to its configurations collection. But with model builder, you can actually start so here we have like model builder.entity category, and we can actually start setting up Fluent API from this point. Category ID dot has column name our ID as an example. So the model builder, you can start configuring your POCOs from right here. One thing, however, that of course if we have a lot of tables, that could get pretty unwieldy. So one thing I'm doing is I have these standalone configuration files. We're going to look at those in just a sec, that allow us to sort of abstract out the configuration work to these standalone files, so we don't have to pollute this on-model creating override with just all of our configuration, because it can get quite unwieldy. But before we get to these configurations, let's jump over to initialization and talk about initialization. So okay, here we go. So the DB context, we just took a look at that object. So iDatabase initializer. So one of the things that Code First provides us, and which is one of the key features, in my opinion, is it provides us several techniques and several approaches that we can take towards the actual creation and initialization of our infrastructure. So when I say the creation and initialization, that physically means create the database as one of the possible options, but also means seeding the database and having access to different behaviors. So the iDatabase initializer is an interface that's implemented by 3 different initializer base classes. These base classes are create database if not exist, drop create database always, and drop create database if model changes. And again, we have the generic syntax here, so back to that, back to the importance of the rich API. It's very easy to use, and we can really use these base classes and have them configured very easily. Another important part, like I had mentioned, part of these base classes and the iDatabase initializer is the seed override. So, such as the context object, the DB context, like we just saw, how it had a onModel override, these database initialization base classes have a seed override, which allows us, that's the entry point, if you will, where we have the opportunity to seed our database with test data or do full-on enterprise synchronization against our database. And so let's take a look at a initializer and see what this means for us. So here we are in our context, and you can see in our context that we, off of this DB database object, we call the setInitializer method, and we pass it in a new type that derives off of one of the three we had mentioned on the slide before. So real quick, let me talk about the setInitializer method, and let's talk about this guy for just a second and what it means to us. So the setInitializer command it's a command that's really going to execute or run the initialization process. So right now you can see I have it in the constructor of my context object. So that means every time my context object is instantiated, this initializer is going to run. That's not always required. That may not even be the case and may be inefficient. As far as this example, it's fine, but I'm telling you this because the setInitializer is just as you would set up a inversion of control container or set up routes in MVC. You just want to do these things once. They're usually at an entry point in an application, such as the global.asax or the main method of a Windows program. The setInitializer is a similar type concept. You really just need to call it once, and it's going to initialize the database based on your settings, and then it's done. So I have it here for the example in our constructor, but the important thing to keep in mind is that this command really just needs to be called once, and it's really up to you as you architecting your code first solution on what the best point is to really initialize your database. I know in my organization, the company I'm working with right now, we have talked about even a standalone console app that could even be part of the build process that can just run this initializer automatically for us. So you can get pretty slick with it. Nonetheless, let's go take a look at the initializers. So, and I hope everyone is doing wonderful today. So here we go. So here's an initializer, and just like with the DB context and everything else revolving around code first, we have to build these objects. So it's truly a code first model. And so again, with the rich API, we can do this very easily. So here we have just a regular class, nothing special about it other than the type it derives from. So as I had mentioned before, we have three types that we derive from when we build out an initializer. So the types again are this create database if not exist, and it's going to do just what it sounds like. If the database doesn't exist, it's going to be created when this initializer runs. And again, we have the generic type syntax where we just pass in the context object so it'll know what context to go instantiate and run. So I'm sure you can start to see how this all starts to play together. Again, our other option is a drop create database if model changes. So if our model changes, say we let's go look at a customer, right? So say we have a customer object, and say we change company name to just company, and we'll say we get rid of name. So we changed our model, we changed our POCO, if you will. This initializer, when we have the drop create database if model changes, it'll actually scrub through the POCO object, scrub through the model schema, and say, hey, this POCO's changed and I have a directive to drop and recreate the database. So that's going to be really good when you're in a time in your development where you just have constant refactoring or if you're really changing your POCO objects a lot, you're really modeling out your domain, you're just kind of in the trenches with development, the drop create database and model changes would work great for you, because it's just automatically, every time you press F5, it's going to fully support changes that you've made to your domain layer, and just recreate the database and have it ready for you to go, seeded with data like we'll see in just a bit. And then we have a friendly guy here called drop create database always. So pretty powerful there. That's going to always drop and your database and recreate it. So you want to exercise caution with that guy in production environments, right? But nonetheless, for quick refactoring, and if you're in a part in your development process or life cycle, it may be very appropriate. But nonetheless, we were coming back to this theme of really having the rich API and object model available to us, so we can really approach architectures from all these different approaches, just based on a couple of easy to use base classes. So let's go look at seeding. And as I had mentioned before, when we have a class that derives from one of these base types, we have a override available to us called seed. And this is built in for us, and it actually has as a parameter a active context. So as we have our Northwind context that we've created here, we have an active version of it that's given to us in this seed override. So this is going to be the entry point in your application where you can start synchronizing your database, again, any way you need to, but also just really start seeding it. And out of the box, it's going to be really easy. Since we have a context object available to us, and it's completely active, we can just go context.set, and then this is the code first syntax that they like to use. So here we can go category, and then we can go .add, and then we can go new category, and then do a little, category ID equals GUID new GUID, and category name equals our name, etc. And then just like with Entity Framework, model first and database first, again we can just go context.save changes, and this actually is going to commit the changes to the database. So again, just like with our on-model building override, where we may not want to necessarily put all our configuration and mappings in that one method, we may want to abstract that out. You can do the same thing with this seed method. There's a lot of neat architectural approaches that can be taken towards seeding. You could use dependency injection patterns and have different IOC containers register different concrete types based on your build environment or your target server, and seed the data with, just from different sources. Or you can, get enterprise and go against a service or another database even. So you have a lot of power and control in this override seed. So here we can see I'm just doing some light seeding, just passing in the context into this method. Again, it's a live context, so here I am just adding customers, no big deal, and then just using our the syntax we had saw earlier, I described earlier, setting a customer and just adding them. So notice we haven't called context.save changes yet, so we're still in a in-memory context object. And then up here, finally, the last thing I do in the seed method is I go ahead and call save changes. So that's the database initializer. So if we sort of back up and do a real quick summary, and to start to see how all these different objects play together. So we create our context object. That's the conceptual representation of our database. We create these POCO objects that, and we'll go look at another one of these. Here's category. We create these POCO objects that are are just really dumbed down getter and setter classes, just very anemic domain models, if you will, or software models or DTOs, however you need to call them, but they're very dumbed down. They don't have any type of tie to any type of infrastructure. So we have our context. We have our POCOs that we're going to represent as tables. We have our on-model creating override that will run automatically for us and configure our POCOs and the representation and expressions in the database. And then we have our initializer here. Again, that can be set from some entry point. That'll actually go into our initializer and start to seed our database, and also set up different behavior that we need. So whether it's create database if not exists, the drop create database always, or if the model changes. So sort of that sequence of events happens, and it sort of provides us that framework and the path towards getting a database up and running. So regarding create database if not exists, let's do a little magic show here. So here we have a database, and let's see about deleting this guy. So here we have just deleted the database. Pretty scary, right? So we have no database. So I can run the application. If we look at our initializer, we see the create database if not exist is set. So it's actually going to physically create the database and infer the types and create the tables based on our POCO objects that we see here. So let's go ahead and press F5. And here we get our application back, our awesome application. And we go to the database, and if I go refresh, here you can see the magic show completed. It actually created the database for us. And here you can see all our different tables. These columns are just the representation of our POCO objects. Here we can see an association table that was created for us via a mapping, which we're going to get into that section next. And all of our other POCO objects. So pretty neat the way that happens. So let's talk about convention and configuration. So we've talked about the DB context object. We've talked about our initializers and the different strategies we have for initialization. And so now we can talk about convention and configuration. So one of the things, again, that has to happen is our POCOs have to be somehow expressed in the database, and somehow they need to be configured. So by configured I mean property names, string lengths, other attributes such as whether they're required or not, relationships need to be set up, foreign keys, primary keys, compound keys, etc., etc. So we have out-of-the-box convention, which is going to kind of get us up and running very quickly. But we have two new approaches that we can take. So we have data annotations, which, again, as I mentioned earlier, these are new annotations that have been released with Code First, and they're basically used to decorate POCO classes and properties for quick convention overrides. So if we just need to do a quick override of convention, like rename a table or rename a column or set up a quick relationship, we can do these via these data annotations. So if we go look at a class, I believe category had some. Here are some actual data annotations that we can start to implement. So, let's stop the application. Thank you. So here we can set a table as a data annotation. You'll notice the namespace, component model.data annotations, and we can just give it a name. So now when category is created, we did a quick convention override, and the name of category will be expressed as a database table named new table name. So we have other ones such as key, which will let the entity framework know that, hey, this property is a key, primary key. We have some other data annotations such as required that lets us know that the property is required, and then some other ones such as string length. And there's quite a large collection of these data annotations. I wish I had the time to go through all of them, but I just don't right now, unfortunately. But there's a lot of good documentation on these data annotations and how they can be used. But it's one way that really allows us to easily, like I'm mentioning, put in quick overrides for the convention-based approach that Code1st is going to use. Also, as we'll see later on in an example, these can be used actually in data validation, and Code1st has a new API that is very specific to Code1st and how it can handle data validation. So we can validate models, we can validate individual properties, and we can validate entities using these data annotations by just merely decorating a POCO property with a data annotation such as required or string length even. We can get into the validation API automatically and very easily. So we'll look at that in just a sec. So those are our data annotations. Okay, I seem to get those confused for some reason. So another approach towards configuring our POCO objects is a new Fluent API that's been released with Code1st, and it's used to configure POCOs programmatically. And it's going to offer us more granular support and complex mapping options. And so all of a sudden we have a real enterprise scalable way, configurable way to really start to handle the fine-tuned details of configuring our POCO objects in the database, and that's going to be in this Fluent API. So those of you who are used to in Hibernate or Fluent in Hibernate, it's very similar API. So let's go take a look at some of the Fluent API examples. So again, let's do a quick summary. We have our context. We're telling our context, hey, go initialize the database right here. In the on-model creating, we are telling our context to add this configuration to the model builder collection. So let's go look at one of these configurations. So unlike data annotations that are actually decorations and attributes on a POCO object, configuration POCO objects using the Fluent API are going to be standalone classes. So again, we start to get into more potentials and options for scalability and enterprise design patterns. The object, the base class that Fluent API classes are going to use is this class called entity type configuration. So just like with the DB context deriving off of DB set, and just as our iDatabase initializer classes derive off of the three different base classes, here again we're coming back to that theme of this rich API and rich model that's available to us. We again have to set up these classes ourselves manually, but with these base classes and the use of generics, it's very easy to use. So just setting up our class with this signature automatically allows this class to be a configuration object that we can use. And so here you can go, we have a class called category configuration, and you can see I gave it a constructor. It's a real handy entry point into the class where we can actually start doing some of these mappings. And like the model builder object in our context, where we had access to the API, so we get access to the API via, here has keys and property and map and whatnot, we have access to this when we derive our classes off of this entity type configuration. So what you'll do here is really start getting into and very fluently configuring your POCO objects. So the different keywords that we have are some of them that you're seeing here, like has key. And the neat thing about this Fluent API is it gives us a lambda type expression. It gives us a lambda type expression that makes it very easy for us to use. So since we're a type of category, our lambda will be automatically inferred for. So here we can just go x lambda expression dot, and then we get all the publicly available properties that are available to us off of our object, and we can easily start mapping. So has key will be something like setting the primary key, but the other big guy is the property here. This is one you'll use a lot, and property is where we can start really getting into the Fluent API, and you can see that I'm going property category name dot is required dot has max length 50, and so on and so on. Here it has column name. I can actually change the name of the column. So here we're changing the name of the description column to category description. So it really provides us entry point into configuring our POCOs. And again, with the lambda expression syntax that we have available to us, description, we just can very easily go is required, has max length 55 or 44. As column type, we can actually put the column type, string or varchar 250 or etc., etc. So that's what's going to be done in these files. So sort of to summarize real quick, they derive off of this type of entity type configuration, and they are automatically available as far as configuration objects, and we automatically, via the generic syntax, have access to the Fluent API and the POCO objects getter and setter properties. So let's talk real quick about relationships. So regarding relationships, there's many relationships that we can start to set up in the entity framework. So one of them is, of course, the one-to-many. We can also set up many-to-manys, and we also have access to navigation properties, just like we had navigation properties in the model first and database first. And then we have several hierarchies that we can use when we have complex types and object hierarchy. So we have table per type, table per concrete type, and table per hierarchy. So let's look real quick. I want to show us a navigation property and how those look and are configured. So when we come into here, and I won't save that. We saw a many-to-many relationship earlier in our example. So if we go look at one of our domain objects, so here's category. And here you can see our category domain object has a virtual iCollection of products. So, and it's an iCollection of type products. So we have our product POCO object here, and then we have our category, and then we have this, once we make a property a virtual, it just becomes a navigation property and allows us to very easily navigate into this. So, and it happens auto-magically, if you will. So here if we go to our DAL service, and let's go get products by category ID. What I'll show you is here we go P. So what the navigation properties are going to allow us is to very easily, when we get an instance of a category, so let's go back to our DAO layer. Let's see. Oh. return null, and then result dot first dot products. So here we're getting a category, or get all categories. So say we went to the first element in this sequence, we could go category dot products, and this would actually give us well, I don't have a result type, so prods equals. This would actually automatically give us the products that are associated with this category through the database representation that's set up. So if we go look back to a mapping, a configuration mapping, local configuration, and we go look at category, well, we can see again by convention here the fact that in our category, go to declaration, the fact that we have a iCollection of products automatically set up the table for us to where we automatically gave products a foreign key to category. So here you can go, you see category ID is automatically part of products. So we have a one-to-many relationship set up for us by convention. But of course, with the Fluent API, we can also have fine-grained control over this in our mappings. So we're about out of time, and so I'm going to jump to the summary of the session and what I want everyone to gather from. So we have other, here we go. So what I really wanted this to be was to serve as a springboard to further professional research into Code First and the release of this great technology. So again, I've been using it for a couple of months now on some applications, and it's been working great. And it's really nice to be able to have that paradigm shift, to be able to work from your domain and model first, your software model first, and not really have to worry about the database too much, and let the database sort of be the infrastructure that just supports or just persists your domain objects, but doesn't really drive your application. And so new data is constantly being released right now, and we should get an official release pretty soon here, so can't wait for that. So one of the things that you should really ask yourself regarding Code First is it right for me and my organization? And what Code First is, it's a tool. It's a tool just like any other tool we have. I mean, so it's not, again, a replacement of Entity Framework, but it's yet another tool we have in our toolbox as developers that we can get and use if needed. So you can ask yourself questions such as, is Code First going to add value to my architecture? How can Code First integrate with my architecture? So like we saw with its rich domain model, there's a lot of different ways to plug it into your architecture, and even enterprise type design patterns like dependency injection. You really have a code model you're dealing with and these base classes and interfaces, so you can think about it a little bit, have all these different approaches that you can implement. And then, what are some of the points of concern regarding the integration of Code First in my architecture? Something you may, need to ask yourself, and, how do I need to do it? What are some of its behaviors that possibly I don't want to participate in? What is it going to do well for me? So, really use this session as a springboard to ask these questions. And again, we're in a real early phase, the community preview right now of Code First, so things are really just getting going with Code First, and I'm really excited about to see what it has to offer us in the future. The last thing I'm going to mention is the ADO.NET team blog. They've done a great job at releasing blog posts around Code First, and even as early as last week, they released a barrage of at least 12 or to 15 blog posts just on Code First. So they're really pushing documentation and instruction on Code First from their blog. So I really strongly suggest taking a look at their blog. There's the address here. And you'll start to see a lot of these examples in place, and you will you can read about the Fluent API, you can read about the pluggable architecture, validation, and the approach, and you can also see what others are saying about Code First and some of the great questions at the end of the blogs that are going on and some of the great discussions. So again, my name is Chris Zavaleta. It's been a real pleasure to be part of this conference, and thank you very much for joining me today for this hour, and have a great day.